We have David and we have Sebastian. So warm welcome, big round of applause, and have fun.
Yes, thank you. So we want to talk about the CAP native task queues, which Daniel teasered already this morning in the keynote, right? When you showed with this REPL. He called it event queues. We came back and forth with this name. We had to submit the title for the talk a couple months ago. So basically now you would find it on as event queues on CAP. Yeah, unfortunately, Thomas couldn't be here today. So you're going to get 2 Node.js demos because I can't do Java. And mine is also not going to be as good as his. But yeah, first we want to do a little bit of an introduction. Why we did that in the beginning, this outboxing thing. Then how we're evolving it. Then David will give you a demo about, yeah, again, CDS queued, what you saw already this morning with the callbacks and these sorts of things. Then Dietrich is going to take over the inboxing topic, talk about that a little bit. SAP internally, that's yeah, the first adopters of that were on the CAP Java stack. And then my second demo, or then I'll give you a demo about how to manage the dead letter queue. So brief history of outboxing. Daniel, again, teased that already. I took audit logging. That was actually our first productive use case. That's why I took it as an example here, right? It's very intuitive to understand. You have some kind of CRUD operations on your CAP application. DPP says you have to write an audit log for this, and you can only commit the change if the audit log was written. So that means that you have a synchronous call to the audit log service. And if that thing is down or the network link is broken, you have a problem because that error bubbles over to your CAP application. You have to roll back the transaction. You have to reject the change, and your user is unhappy. So what can we do about it? We introduce the outboxing. That means we first write into our local database in the same transaction with atomicity that we need to, at some point in time, write this audit log to the audit log service. And then, of course, we're going to try to do it as soon as possible. And we can retry this, so adding resilience to the matter. But basically, you will never have this problem that you have to reject a change due to some upstream server not being available. And also the phantom events that we heard about. There's also the situation that you write an audit log to the audit log service, and then for some other reason you have to roll back the transaction. Then you would actually have to tell the audit log service, so that was actually a false audit log, right? So you have both directions. And that's how we then came up with this outbox pattern. And if we just look at that pattern itself, you see, yeah, there's some message in the database, some intent, that's something you have to do. You have a runner, and then it can resiliently send it to the audit log service or any other remote system, or actually it could be a message you want to send to a message broker. It could be some kind of task that you want to run server internally, just not inside the synchronous request that you get from the UI, but sometime afterwards. So then the outbox gets extended by background tasks. And actually the origin of how this information or this workload comes into your database is irrelevant, right? It can come from a UI request via OData. It can come from some other message broker in some kind of CQRS scenario. So you're the upstream, you're the audit log service, you're the backend with master data, whatever. You get via messaging some kind of task or via HTTP, doesn't matter. You put it into the database, and that's then the inbox that Dietrich will talk more about. And now finally, the last step we want to do in generalizing this outbox pattern is offer these callbacks that you saw in the demo, in the keynote demo, where you just register once this task at the remote instance was successfully processed or also failed to be processed eventually after 20 retries, whatever you configured, then you will get a notification and you can do follow-up things, you can do compensations, you can basically go towards SAGA patterns with these distributed transactions. Yeah, so that's our plan, and I would now hand over to David for the demo.
Thank you, Sebastian. Hey, everybody. You can see everything, you can hear me? Perfect. So I start with an already existing project just to give some jump start. And first, I'm going to show you the schema. So it's a typical bookshop example, which you hopefully all know, which has, unsurprisingly, the entity books with ID, title, and stock. Stock is very important later on. And also the orders entity, where I just save an ID in the book, okay, which I want to order. I also expose this stuff in CDS. So I have my entity books as well as a bound action on books. So I can order a specific book. And I also have an implementation for this action. This is a service on order books. And I can fetch the ID from this order request. And what I want to do is I want to update my books entity where I decrease the stock by 1, so minus equal 1. But I want to add a guard. I only want to do that when the stock is greater than 0. It's an atomic operation, so it works. If for whatever reason the book is not there or the stock was not bigger than 0, then the result will not be equals to 1. And therefore, I throw a error that the book is not available for whatever reason. Now, the interesting part is, once I decrease the stock of a book, I also want to order it, right? I want to set this ordering process in place. So what I do is I generate a UUID with CDS utils UUID, and then I take the order service, which I show you in a second, and I emit the event order book with a payload, which you see here, and then I return order created. Now, what is this order service? It's something I connect to here. That means in the package JSON, there should be an entry for order service, which is this guy here. It has a custom implementation I wrote before, so let's navigate here. And you can see here is this order book action, which I define on the order service. And it's also relatively boring. It takes ID book from the payload, logs something, waits for seconds. Please don't do this in production. It's just to simulate some processing time. Then every third attempt will fail because we're in the real world where errors happen. And then I insert an entry in the orders table, log that everything is successful, and return the ID. So super boring stuff. Okay, now if I run this, and let me show you this initial handler so you can see what's happening. I can run this in watch mode, and I spawn another terminal where I can send some call requests. Now, with this call request, I trigger this action. No, actually not, I don't. It's another call request. This call request is used to trigger the action order on book number 1, maybe a tiny bit smaller. So if I run this, you can see that this 4 seconds simulating processing time also has an effect on this HTTP request. Let's do it again. So it takes a long time for this HTTP request to return, and you don't want to have users waiting. So what we can do, instead of having this thingy here to be a synchronous operation, which the caller has to really await, we can make it asynchronous. And therefore, we can immediately return and don't have to wait for the result. So the only thing you need to do is to write CDS queued, the D, and then you make a normal service a queued service. That means every operation you use on it, in the end, either send or emit is called, will be queued. So let's try it again. Server's already restarted because of CDS watch. And you can see I immediately get the HTTP response. I don't have to wait. And asynchronously, the order is now in process and now successful. And I can do it again. You can see HTTP request immediately returns. I can even send it in parallel, and then it will be processed also in parallel. Okay, and I told you before, every third attempt to order a book will fail programmatically. And you can see it also here. And if this emit fails for some temporary reason, then the outbox processor will retry it, and then eventually it will be successful. Okay. Now, to show you what's going on under the hood, I can also set debug to queue. Then you can see a little bit more what's actually happening. So if I send a post request, then this line here on the left, this emit on a queued service, will not send the event to the service directly, but instead it will write the whole event, including the payload and other stuff, into a database table, CDS Outbox messages it's called. And once everything is committed together with whatever you did before with the database, so we have transactional safety, whatever is committed will then be in another transaction processed afterwards. So this emit eventually leads to writing a message to the queue, Then we commit everything together with the main transaction in the main transaction. And once this is done, we fetch the messages from the table, and then we process them. You can see that here. And then the order service actually receives this message, processes it as you saw before. And once everything is done, we delete the message from the outbox table because we're done. Okay, and then the processor also knows I'm done. Let me show you the error handling. So the second request also succeeds, as you saw before. So also boring, but the third one will fail. So what happens? We write the message to the queue, respond to the client, hey, the order was created, even though we don't know at that time yet if the order will be successful or not. I'm going to come to that in a second. We write it to the queue, we fetch the message, we process the message, or at least we try to. Then we start sending this event to the order service. It will start processing it, but then it fails, and the order service returns an error. The processor knows about it, and basically says some messages could not be processed, that you also saw in the keynote today. And we process it again after some delay, and it will be exponentially increasing. And the second time it will be successful, and then everything is done. Now, the question is, what happens with errors which cannot be resolved if you try it over and over and over again? That's what we call unrecoverable errors. Now, the processor usually tries it until some max attempts limit is reached, and then it will just stay in the table. So you don't lose that information, and you can debug and see exactly what's going on and why that happened. We can also mark in our order service that certain errors are unrecoverable by setting the unrecoverable setting to true. That indicates the message processor, hey, don't even bother retrying this thingy, it will fail all the time. So if we do that, and I send the first two, which succeed, boring, but then the third one, which will fail now with an unrecoverable message, so let's see what's happening there. So now it's in process and it will fail. And now the outbox processor knows, okay, it's an unrecoverable error, it will print it, and then it will just set the attempts field to max attempts, and then it's basically invisible for the outbox processor and will remain in the table. Now, the problem here now is if we tell the client, hey, the order was created and we already decreased the stock here. We already decreased the stock, and then the order cannot be processed. It's kind of bad because then we still have books and others should be able to order it. So what I want to do now is I want to react on a failed message. And that's also what you should always do. Always expect failure. Stuff can happen. So what we can do is we can, on the order service, register a handler with the same name as the event you emit, /# failed. And once you do that, you can register a callback, and this callback will be executed when the message processor notices that something really couldn't be processed, okay? And what we do, we basically do the same thing, but this time we increase the stock because, you know, the order didn't went through, so we can increase it again, and we can just take the book out of rec data and just use it here, okay? So, let me spawn another terminal, run the thing. And in this other terminal, I want to show, let's see, this guy here. I want to show the content of book 1, just to see. At the beginning, it has a stock of 10, okay? And now I'm going to send 3 order requests, and the third one will fail. So let's do that in parallel. And I send this thingy, and you can see it's 7. Why is it 7? Because we immediately decrease the stock for each of those orders and then process the orders in asynchronously. But one of them will eventually really fail. Then the handler will be triggered to increase the stock again. So now if I run it again, you can see the stock is 8. It was increased again because we noticed the order failed. So you will have a database state which is not consistent for a certain point in time, but eventually consistent when you take all operations into account. All right. Now, the last thing I want to show is that it's very symmetric to asynchronous communication with, let's say, messaging. So let's do that also. We can connect to a messaging service. And now you can also switch this order service with messaging. So now the plan is to just emit those events to a messaging broker in between, which enables us to move the order service somewhere else. It could run in a completely different application. So we just register everything on the messaging service. Hashtags, unfortunately, are not allowed, so we just remove it. We're free to choose whatever name we want. And yeah, we also have to adjust the order service. So we get the messaging service and we say messaging on order book. And the only thing I need to change is react on this error, because we also want to send an event in case of an error. That's the only big difference, let's say. So we wrap everything into a try catch block. And if there's a failure, we just emit this order book failed event. Format it. Okay. So let's see if that works. I run my application. I hope I'm online. Yeah, I'm online. That's good. Now let me run this thing 3 times as before. I run the curl request. You can see the stock is 7. Now the thing really failed, and now it's 8. So you can see the code is pretty much symmetrical, and I like when things are symmetrical. And it doesn't matter if you send this stuff to a messaging service, to a local service, to a queued local service. Should be the same. Should feel mostly the same. All right. And the last thing I want to show is the inbox, which is also the feature, because we noticed also thanks to our AFC colleagues that this whole outbox table is kind of useful for all kinds of stuff, not just for the outbox. Still called outbox messages, but it's now used for all kinds of stuff, also for the inbox, which might be a bit misleading. So we can configure the messaging service to not, when a message comes in, process it directly, and when everything is successful, tell the message broker that it's fine. Instead, we want to first store it in the outbox table, and then process it asynchronously and immediately tell the broker that it's done. Yeah, I'll open it. So the only thing we need to do is in messaging say inboxed true, and now the same thing works. By the way, messaging services are automatically outboxed, so when you call messaging emit, it will always go to the outbox table. And yeah, after the emit, you can see it only in the logs. It behaves the same, but in the logs, you will see that when a message comes in, that's this line, this log line here. We first write it into the queue and then tell the broker immediately, yeah, we got the message, and then it will be processed. And what the inbox is used for will now be shown in the slides. Over to Dietrich.
So yeah, I show you the inbox and what you can do exactly with your application with the inbox. And for those of you who's not familiar with the inbox, I show you a real life analogy. So imagine you have a mailbox, mail delivery service, and you don't have any mailbox in front of your house. And if you receive a mail, then the postman needs first to ring the bell, waiting for you to answer. And if you don't be at home, then he takes the mail back to the post office and tries this process maybe for the next few days. And this has, of course, a lot of implications, negative implications. And if you think of the post office, they need a space in the office to store the undelivered messages, and maybe more employees to run this redelivery process. And also for you, the delays between the receivement of your mail. And for that reason, the simplest way is to put a mailbox in front of your house, and everything is solved. The postman doesn't really even need to ring the bell to deliver the message. And similar to our messaging, we have the same problem. If you think of queue-based messaging, then you need more space for your queues if you have a high amount of messages, high traffic, and also you need more to pay for deliverment because you pay for the amount of messages. And to configure this, as David already showed, you just only need one property. You can see it on the left side, where you can switch on the inbox on the inbound messaging channel. And from the technical point of view, it's actually the same like the Outbox, and that's why we can reuse our Outbox APIs and our techniques to use it in conjunction with the inbox. The difference is just only the direction of messages. And as you can see on the right side, you can use you can configure your custom Outbox and connect it with your custom messaging service, which is in turn connected to any kind of messaging infrastructure like Redis or Event Hub or Kafka, and use the Outbox APIs to implement your custom application logic for your needs. And one of the examples could be maybe the exactly once pattern. You just only need your custom messaging service, your custom Outbox service, and you can add custom handlers with our common APIs and implement your redundancy filter for the events in order to implement the exactly once pattern. This could be one of the use cases. There could be also much more, but that's actually it. And as you can see, you don't need anything to do, just only to configure everything together in order to use that. Yeah, and that's it.
Yes, thank you. Now I'm gonna continue with the second demo. So originally the second demo would have included this inboxing part in actual demo. So we had to pivot a little bit and shift things back and forth. As I said, mine is going to be a little bit slimmer, so I'm not going to really have messaging involved in my demo. But I hope you can get the gist of what I'm trying to show you. And basically, the question is, if you, it's too small? Sure. I'll go like this. If you activate the inbox, right, then you're going to accept whatever message you get from the broker and put it locally into your database. Oops. This? No. Dark theme, total, okay. But David's was also black. Okay, it was bigger, fine. Okay, so yeah, as I was saying, the messages are going to be in your database, right? So you basically then deactivate any replay features that your message broker may have, right? Kafka has something like that, not all of them have that, but you acknowledge the message, and if during processing something goes wrong, they're from the broker, they're gone, right? But you have them locally, and that's what we then call the dead message queue. And our CAP experience team in Berlin and Potsdam is going to be working on managing that thing a little bit more professionally, but you can do it now already, right? Because the messages is just another table that you have in your database. And of course, you can create your own service and have handlers that allow you to, what we then call revive them or modify them if the payload was just invalid, do some compensating stuff so that they will then be successful. And that's what I'm going to basically show you in this demo. So I also have this catalog service, and this catalog service connects to a warehouse service and basically orders books that are low in stock. But that is going to be just another local service now in my CAP application for this demo. Basically, what we do is when we get the list of books, after if we identify a book that has less than 3 available in stock, we're going to tell the warehouse service asynchronously, please send us more of that. And basically, you can also order books, right? And if they're out of stock, then you get an error. On the warehouse service side, very, very primitive. The shipment has not arrived yet. It's false. Once we call the restock action, the shipment has arrived, and this warehouse service will be able to provide more books, right? And then we'll quickly see what happens here. I'm going to start the thing. Go. Right, okay, so we're up and running. and we're going to get the list of books, and we see, okay, Wuthering Heights, stock only at 1. We are going to contact the warehouse service and tell us, please, we need more books. I've put the max attempts for this demo to 3. So you see, it tried 3 times resiliently, right? But all 3 times we could not provide more books here. Now the question is, this thing is now a dead letter, basically. How can I manage this, right? And there's actually on Capire, there's a great article already of how to do that. That was once done by Thomas. Yeah, we had adjusted it to for the Node.js runtime as well. Basically, we have this Outbox dead letter queue service with an entity dead letters, and we can revive them or we can delete them. And now the question is, we need a little bit of custom coding to, of course, identify which of the entries in this table are really the dead letters and which are not. So we have a little handler here that basically just checks the max attempts current configuration, right? You can change it so it's not a static, and we just append it to the SQL that will then select the current letters from the message and return to the service. So really very, very simple, just adding a static filter. And now we can add a UI. Even I was able to do that with the Fiori tools. So we're going to press go, and we see, okay, we have now this one dead letter that says, okay, we need more of books with ID 1. So for demo purposes, I made the message a little bit shorter. That would have been the real JSON payload. And the last error was none to give. And I tried it 3 times. So now basically I see, okay, there's nothing wrong with the message itself, right? There's no typo in there that I have to correct in order for it to be successful the next time. I maybe send it to a remote service. Otherwise, I could build in some update functionalities here, some modification functionalities if I wanted to. I'm just going to say, okay, I'm going to have to wait until I know that the shipment has arrived. And let's just do that quickly, telling the warehouse service here that the shipment came. Okay, the shipment has arrived. We have the log message. So now I expect if I just revive this message, that it will be retried and then successfully. So let's see if hopefully that happens. The UI refreshes automatically. And yeah, we see we got the restocking books log output that was emitted here because this we need more action was triggered again. This time the shipment had been there already, so we were able to supply the catalog service with some more of these books. Right, so that is basically delete. Of course, you shouldn't just say, okay, this will never be successful. You can just delete the messages. And basically what we do here in order to implement all of these things are these little lines of code. We have a revive one. So what do? We update and say the attempts are 0. Pretty easy. And then we're going to manually just flush the service, right? So we say we trigger reprocessing again. Actually, in the future, we are going to do this automatically, but right now you have to do it manually here. Delete is a delete. Pretty simple. Yeah, and then for that part, and now one thing we teaser, and then looking at the time clock, I think we have time for that. Now maybe, okay, I don't want to build this UI. I just want to have some information. How many messages do I actually have in my dead letter queue or in my outbox in general? And that's where OpenTelemetry comes in. And pretty soon in CAP.js telemetry, okay, I should have logged in this morning. In CAP.js telemetry, we're going to have this, provide this out of the box. For Java, the ecosystem is a little bit differently. You get most of it for free, but that means we don't have a plugin where we could supply that logic. So again, on CapHire, you will find documentation on how to do it yourself. But we actually now are collecting metrics about the messages table. And I didn't build any fancy dashboard, so this is really basically just the number of metrics, right? It says we're collecting 7 different metrics right now and reporting them. If we scroll down a little bit, we will see then, okay, there was 1 cold entry, so that those are the ones that need to be revived. At the end, we see, if I scroll down here a little bit, that they are medium average time in storage is 171 seconds. So I have to maybe speed up my demo capabilities a little bit so they're not in there that long. But I mean, yeah, we kind of collect some metrics, we report them, you can look at them in OpenTelemetry. And if you know how to do this, you can build fancy dashboards there. Yeah, so number of outgoing messages, remaining entries, and all these sorts of things. So you can really build really sophisticated monitoring capabilities on your CAP application to see if it's running healthy, if you see that the messages that are coming in are being processed. Outgoing stuff, of course, as well, right? These metrics are not just inbox or outbox. They can also be the background tasks all in one. Yeah, and those are our general purpose task queues. And with that, thank you very much. And yeah, we're ready for the Q&A. And please participate in the survey.
Exactly. Awesome. All right. First question. Perfect. So first of all, thanks so much for the session. I think those features really close an important gap. Two questions, actually. Is it planned that we will offer also a more managed version to handle those kind of errors? Also thinking about application interface framework that we also have on S4 side, so that business users might be able to really reprocess those business errors with a nice UI, change payloads, stuff like that. And also one additional question: is it actually advised to, so thinking about a microservice application, we have multiple microservices, is really to advise to have an inbox for each individual microservice? Wouldn't it be easier to manage it, in a central event broker and just have it in one place and really see all those inbox messages? What is kind of the best practice there?
So maybe regarding the first question, I mean, we from the CAP framework. Hello. So we from the CAP framework, we don't know what errors are actually thrown by the business. So that's only something the custom implementer knows. But what they can do, as I showed in the demo, you can register on this failed event. And when this happens, they can decide whatever they want to do with that message. They can, for example, modify the payload. They can read it from the messages table, parse the JSON stuff we put in there, and modify the payload to then try again later. So all that is completely possible. And regarding your other question with a, let's say, global outbox, we have indeed some stakeholders which use one HANA instance for multiple microservices, right? And they would share one outbox table, and there's also a way to isolate it properly, which is not isolated by default, because by default we assume that this database this HDI container belongs to this application, but we can isolate it. So also that is possible. But you would of course have access to one database shared across different microservices.
Just to add to the first one, so again, I would like to point out the CAP experience team that's being formed and getting started recently. The Berlin Potsdam team, and they also have a slot presenting their developer dashboard. Yeah, they're going to be tackling these operation topics, right? So there's also we're expanding from runtime to a little bit more, making it manageable.
Thank you. Any other questions in the room?
I would like to ask about the unrecoverable messages. So I understand that you worked on the database consistency, but still the service endpoint returned a positive message with the decreased quantity. So I would like to understand how that should be handled.
Oh, hello. Yeah, so when the request came in, we immediately decreased it, right? And then an unrecoverable error could happen. And then the database would be in an inconsistent state because the stock was decreased, but we haven't actually processed the order. And that's what I showed with this failed handler. So what I did is I registered a failed handler, and then I reacted upon this unrecoverable failure. Could have also been a failure which at some point reached the max attempt speed. Doesn't matter. At some point, it will not be processed anymore. And then I can react. And then I can increase the stock again. So for a short period of time, the database will be in an inconsistent state because the stock was immediately decreased, but the order has not yet been successfully processed, nor it has failed completely. So it's kind of a weird state. But once we react on the failed message, then we can put the database again in order and increase the stock again. So afterwards, it's kind of as if nothing had happened.
But when you call the endpoint, the message, the return
HTTP
message
endpoint?
that you receive is a positive message saying that it was decreased, right?
Yeah. So you can also answer to the user, we try to create an order or something like that. So you can also change the message. I just kept it as simple as possible. But the truth would be, hey, user, we try to create this order with this order number, but it could fail in the future. So that would be the complete error message. But we don't want to be too pedantic in the error messages.
Right, we do have time for more questions if there are any.
Actually, that's a good question.
Can you please repeat the question?
Sorry, yeah.
Everybody
So
online?
the question was, what happens if this failed handler fails, right? The database is temporarily down or something like that. Where the failed message is also an outbox message, so it's also in the database table. So if the handler fails, it will be retried. But at some point, it becomes a little bit Inception style errors, right? But it will be retried. So if the database is down and it cannot be processed, it will be fixed. And if everything goes wrong, let's say this failed handler really cannot be executed, and the max attempt is reached, then you will see it in the database on the messages table, and the developer can look at it, or the people who observes the app can look at it and see, okay, that needs to be updated.
Right. Another round of applause for Sebastian, David, and Dietrich.